The main breaker inside an electrical panel does indeed act as a disconnect. Its primary function is to protect the electrical system from overloads and short circuits, but it also serves as a means to shut off power to the entire panel. This is a crucial safety feature. When the main breaker is switched to the off position, it interrupts the flow of electricity from the utility power source to all the circuits within the panel. This allows for safe maintenance, repairs, or troubleshooting to be performed on the electrical system without the risk of electrical shock. It's important to understand the difference between a branch circuit breaker and the main breaker. Branch circuit breakers protect individual circuits within the home or building, such as those that supply power to lights, outlets, and appliances. The main breaker, on the other hand, protects the entire panel and all the circuits connected to it. Think of the main breaker as the master switch for the entire electrical system. When working on any electrical system, it's essential to identify and locate the main breaker. Before beginning any work, turn the main breaker off to de-energize the electrical panel. This significantly reduces the risk of electrical shock or electrocution. After switching off the main breaker, it's always a good practice to test the circuits to confirm that the power is indeed off. This can be done using a non-contact voltage tester or a multimeter. These tools can detect the presence of voltage in the circuit even after the breaker has been turned off. If voltage is still present, it indicates that the circuit is not properly de-energized, and further investigation is needed before proceeding with any work. There are several reasons why a main breaker might trip or need to be turned off. Overloads occur when too much current is flowing through a circuit. This can happen when too many appliances are plugged into the same circuit, or when an appliance draws more current than the circuit is designed to handle. Short circuits occur when there is an unintended connection between two conductors, such as a hot wire and a neutral wire. This can cause a large amount of current to flow through the circuit very quickly, which can damage the wiring and equipment. Ground faults occur when there is an unintended connection between a hot wire and ground. This can happen if the insulation on a wire is damaged, or if an appliance has a faulty ground connection. Ground faults can be particularly dangerous because they can cause electrical shock. If the main breaker trips frequently, it indicates that there is a problem with the electrical system. It's important to investigate the cause of the tripping and correct the problem before resetting the breaker. Continuing to reset the breaker without addressing the underlying issue can be dangerous and can damage the electrical system. In some cases, the main breaker may need to be replaced. This can happen if the breaker is old or damaged, or if it's no longer able to provide adequate protection. Replacing the main breaker is a complex and potentially dangerous task, and it should only be performed by a qualified electrician. There are several different types of main breakers available, each with its own characteristics and capabilities. The type of breaker that is appropriate for a particular application will depend on the size of the electrical panel, the amount of current that the panel is designed to handle, and the specific requirements of the electrical system. Some main breakers are equipped with additional features, such as surge protection or ground fault protection. These features can provide additional protection for the electrical system and can help to prevent damage from power surges or ground faults. It's important to choose a main breaker that is properly rated for the electrical panel and that meets all applicable safety standards. When installing a main breaker, it's important to follow the manufacturer's instructions carefully. The breaker should be installed in a location that is easily accessible and that is protected from moisture and other environmental hazards. The wiring connections to the breaker should be made securely and properly, and the breaker should be tested to ensure that it is functioning properly. Working with electricity can be dangerous, and it's important to take all necessary safety precautions. Always turn off the power before working on any electrical system, and always use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. Electricians have the training and experience necessary to safely and effectively work on electrical systems. They can diagnose and repair electrical problems, install new electrical equipment, and ensure that the electrical system meets all applicable safety standards. When choosing an electrician, it's important to select one who is licensed and insured. This will protect you in case of any accidents or damage that may occur during the work. It's also a good idea to get several estimates from different electricians before making a decision. This will allow you to compare prices and services and to choose the electrician who is best suited for your needs. In addition to serving as a disconnect, the main breaker also plays a role in protecting against overcurrents. Overcurrent is any current in excess of the rated ampacity of the equipment or conductors. This can be caused by an overload, a short circuit, or a ground fault. When an overcurrent occurs, the main breaker will trip, interrupting the flow of electricity and preventing damage to the electrical system. The main breaker is designed to trip at a specific current level, which is determined by its ampacity rating. The ampacity rating is the maximum amount of current that the breaker can safely carry without tripping. It's important to choose a main breaker that has an ampacity rating that is appropriate for the electrical panel and the circuits that are connected to it. If the main breaker trips frequently, it may be an indication that the electrical system is overloaded. This can be caused by too many appliances being plugged into the same circuit, or by an appliance drawing more current than the circuit is designed to handle. In this case, it may be necessary to reduce the load in the circuit or to upgrade the electrical panel. It's also important to ensure that the wiring in the electrical system is properly sized for the amount of current that it is expected to carry. If the wiring is too small, it can overheat and cause a fire. The National Electrical Code, or NEC, provides detailed requirements for the sizing of electrical wiring. The NEC is a set of standards that is used throughout the United States to ensure the safe installation and maintenance of electrical systems. The NEC is updated every 3 years, and it's important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It's a valuable resource for electricians, electrical inspectors, and anyone else who works with electrical systems. One important aspect of electrical safety is grounding. Grounding is the process of connecting the electrical system to the earth. This provides a path for fault current to flow back to the source, which helps to trip the breaker and prevent electrical shock. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the electrode to the electrical panel. The grounding conductor should be sized according to the requirements of the NEC. Another important aspect of electrical safety is bonding. Bonding is the process of connecting together all of the metal parts of the electrical system, such as the metal enclosures of electrical equipment and the metal conduits that contain the wiring. This helps to ensure that all of the metal parts are at the same voltage potential, which reduces the risk of electrical shock. The bonding system typically consists of bonding jumpers that connect together the various metal parts. The bonding jumpers should be sized according to the requirements of the NEC. In addition to the main breaker and the branch circuit breakers, there are other types of overcurrent protection devices that may be used in an electrical system. These include fuses and supplementary overcurrent protection devices. Fuses are similar to circuit breakers in that they interrupt the flow of electricity when an overcurrent occurs. However, fuses are single-use devices, meaning that they must be replaced after they have tripped. Circuit breakers, on the other hand, can be reset after they have tripped. Supplementary overcurrent protection devices are used to protect specific equipment or circuits. These devices are typically smaller and have a lower ampacity rating than the main breaker or the branch circuit breakers. They may be used to protect sensitive electronic equipment from damage due to overcurrents. When working on electrical systems, it's important to be aware of the potential hazards and to take all necessary safety precautions. Always turn off the power before working on any electrical system, and always use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. The main breaker acts as a disconnect for the entire panel, offering a critical safety feature for maintenance and emergencies. The main breaker is usually located at the top of the electrical panel and is larger than the other circuit breakers. The amperage rating of the main breaker is typically printed on the breaker handle. For example, a 200 amp main breaker is designed to protect a 200 amp electrical service. The size of the main breaker should be matched to the size of the electrical service. If the main breaker is too small, it may trip frequently. If the main breaker is too large, it may not provide adequate protection against overcurrents. Electrical panels are typically rated for a specific voltage, such as 120/240 volts. The voltage rating of the electrical panel should match the voltage of the electrical service. It's also important to ensure that the electrical panel is properly grounded and bonded. Grounding and bonding help to protect against electrical shock and fire hazards. The grounding electrode conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe. The bonding jumpers should be connected to all of the metal parts of the electrical system, such as the metal enclosures of electrical equipment and the metal conduits that contain the wiring. Electrical panels should be inspected periodically to ensure that they are in good condition and that they are operating properly. The inspection should include checking the breakers for any signs of damage or corrosion, testing the breakers to ensure that they trip properly, and inspecting the wiring for any signs of damage or overheating. If any problems are found, they should be corrected immediately. Electrical safety is a serious matter, and it's important to take all necessary precautions to protect yourself and others from electrical hazards. Always turn off the power before working on any electrical system, and always use appropriate safety equipment. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. The main breaker serves as a critical safety component.